Okay, so take two. I had to delete the last video because I ran out of space. Hopefully that won't be a problem. Alright, so yesterday you did a worksheet, the packet where you worked on the cars, which you loved so much, where we did the fundamental counting principle, the combinations, and permutations. So we're going to talk about those three. Okay. In your notes, what I'm going to do is just make a giant chart, and hopefully I will space this out right. So, because I know you want me to write big. I got fussed at for not writing big last time. Okay, so here's my giant chart. Beautiful. And the main thing is I'm going to give you the example problems. That's what's going to really, hopefully, make this make sense. I'll put permutations down here because you know most of that, and I don't have a lot of space. Permutations. That is right on the edge. Get it? Oh yeah, you can see that. Okay, in the middle I will put combinations, so those are side by side. Okay. And here I'll put the CPI, fundamental counting principle. Principle, not principal, principle. Okay, so let's talk about, we're going to work right to left, pretend we're in a foreign country. So my notation for permutations is National Public Radio, NPR. Okay, N is my number, my total options. Okay. R is my good. It is my number, what I choose. Is what you choose. And that actually says choose this time. If you can see it, and you can. Okay? Combinations notation. Very, very similar. N, C, R. Letters mean the exact same thing. I'm going to just put total, choose. Okay? The notation for fundamental counting principle is even easier. There really isn't notation. It is just N times R. Now, this is not your total and your what you choose. This is... Actually, I really shouldn't put N and R. Let's do, we're going to do X times Y. This is option 1, and this is option 2. Okay, so yesterday, Matt, when you did this, you said, oh, well, there are 5 types of cars and there's 7 colors, and you knew immediately you needed 35 pieces of paper. Okay, that was what you did. You multiplied your option 1, which is the number of cars, by the colors and got 35. So, hopefully everyone else did that in your head, but that's what it is. So, that's your notations. I'm going to let you get that, get out of your way, pause it now. Got it. Okay, so, notation, now we're going to talk about formulas. Okay. Try not to erase my lines. So, my formulas. For permutations, you know, it is n factorial divided by n minus r factorial. Okay? Here's your example. So I'm going to show you the shortcut for permutation. So if I have 7p3, right? It would be this. It would be 7 factorial, so 7 times 6 times 5 times 4 times 3 times 2 times 1. Divided by, what is 7 minus 3? 4. Good. So 4 factorial. 4 times 3 times 2 times 1. These bad boys cancel. And I'm left with 765. Now, the shortcut is this. How many numbers was I left with? Oh, I can't talk this morning. 3. Okay, and here's my 3. So what you do is when you see this notation, you simply go, oh, well, that's where I'm starting, and that's how many numbers I'm writing. So I just write 7 times 6 times 5. One number, two number, three numbers. Put in your calculator, you're going to answer. This is 30 times 7 is 210. Okay? Now, that was permutations. Hopefully you knew all that. Okay, I'm erasing it. And let's do combinations. Combinations is harder. There's not really a shortcut. Whitney, I'm going to get that for you. Okay? Because I know you're OCD. Now, let's do this. Here's your formula. And then we're going to do the exact same problem as yesterday and see if we get the same answer. And it's n factorial. It looks very similar to permutations. Divided by n minus r factorial times r factorial. Yesterday, we talked about a company was buying 5 cars. They were buying 3 cars, but the dealership showed them 5. So we said how many different combinations could they pick 3 cars out of the 5. So their total options are 5. We're doing a combination and we're picking 3. Okay? So if I plug this in, I get 5 factorial divided by 5 minus 3 is 2. So 5 minus 3 is 2. So 2 factorial times r factorial times 3 factorial. So if I write all that out, I get 5 times 4 times 3 times 2 times 1 over 2 factorial, so 2 times 1 times 3 factorial times 3 times 2 times 1. This guy marks out, out. I get to 20 over 2. And if you remember from yesterday, 20 divided by 2 is 10. And that's what we got yesterday. When you marked out all your options, the ones that overlapped, you got 10. Very good. That's combination. Write that down. So, crap, I forgot to write this. This is a note card. Okay? Your notation is a note card. Alright? And now we're going to talk about the fundamental counting principle, which I kind of already did. So the formula is that x times y. I'm just going to put this up here too. It's x times y. So if you had, like we said, we had 5 cars, 7 colors, you just multiply it and you get 35. Okay. And I'm erasing. So, what I'm going to give you right now is the most important part. It is how in the world do you figure out what formula you're going to use. And that's what all today's work is about. Picking the right one. Now, and solving. So, if I tell you, I'm going to use the exact same numbers for everything. We're going to use 6 and 4. I don't want to use 3. Let's do 7 and 3. 7 and 3. So, there are 7. What can we combine? Let's do, I'm sorry, but we're going to do cars and colors again. There's 7 cars that come in 3 styles. That should be a period. It's not a question. There's 7 cars that come in 3 styles. No. How many types of cars do we have? Okay. Now, am I combining anything? Am I putting anything like in groups? Or am I putting it into places like first, second, third? Or the first 3 people in line? Or anything? No. I literally just have this option and this option, and we're going to kind of like put this option on this one. So we're going to put this color on this option, this color on this option, this color on this option. Like, once again, like the buffet problem. So it's like if I have 5 breads, 3 vegetables, and 2 meats. Literally just multiply everything out. So, I see my option 1 is 7, see option 2 is 3, and multiply. 7 times 3 equals 21. Beautiful. I'm moving permutations. We're going to go easy to hard. So, now, I'm going to, my company is buying 3 types, say I own my construction company, like I will in the future, Nisa. So I'm buying 3 types of drills. 3 types of drill. Home Depot shows me 7 options, and I tried them out. In how many ways I'm going to stand in your way, I'm sorry. Can I rank the 7 options first through third? Okay. My company is buying 3 types of drill. Home Depot shows me 7 options, and I try them out. In how many ways, gosh, my grammar is terrible. How do y'all handle me? In how many ways can I rank the 7 options first to third? So, if I'm ranking first to third, how many drills am I choosing? Great, 3. So I'm picking 3 drills, okay? And it's out of how many options? 7. So 7 is my what? Good, N. 3 is my R. So now I'm going to rewrite this and solve it, because that's all you need to find is N and R. Now, why is this a permutation and not a combination? Because I'm putting them in an order that matters. First, second, third matter. Like, that's how I'm going to buy them when I rank them. Therefore, if it matters, order matters, it is a permutation. Remember, I want you to think of a lock. Locks are called combination locks, but that's wrong. They should be called permutation locks. Why? Because the order of the numbers matter. Okay. So I'm going to erase that and solve it. Remember, N is 7, R is 3. I just ran out of room. You don't have to erase it, obviously. So I have a 7P3 problem. The long way and the short way. Long way is 7 times 6 times 5 times 4 times 3 times 2 times 1 over 7 minus 3 is 4. 4 times 3 times 2 times 1. Cancel out. 3s and 4s. 7 times 6 is 30. Nope. We're going the other way. 6 times 5 is 30 times 7 is 210. Easy way. Start at 7, write 3 numbers. 7 times 6 times 5 equals 6 times 5 is 30 times 7 is 210. Beautiful. So I could write those 7 drills in 3 places 210 different ways. Aren't you glad to make you do that? So I'm erasing that. Hopefully you got it. I'm out of your way. Boom. Now, combination. Let's not buy drills this time. Let's buy, I don't know. We'll just deal with people, okay? 7 students line up at the door. Yeah. At the door. I put them in groups of 3 to walk to the cafeteria. Apparently you need 2 buddies to walk to the cafeteria. Okay, 7 students line up at the door. I put them in groups of 3 to walk to the cafeteria. How many ways could I group them? Okay. So do you see that the order does not matter here? I'm just putting them in groups of 3. Not the first 3 people in line, or not the last 3 people in line, not first, second, third, not president, vice president, and head of state, whatever. I am literally just getting groups of 3. So, since I'm just getting groups of 3, it doesn't matter about the order, I'm going to use a combination. So I'm going to have something see something. Well, 7 is my total number of students, so that is my N. And 3 is how many I'm choosing, so that is my R. Okay, I'm going to erase this to give myself some room. Hope you got it. So now I've got here, I know you're freaking out. Now you might be freaking out even more. Okay, so we've got 7CR. No, we don't. 7C3. That's what we have. Man, it's early. So, my formula, once again, I'm going to write it because I need a beat in your head. N factorial over N minus R factorial times R factorial. So, I'm going to write this down here. 7 is my N, so I'm doing 7 factorial. 7 times 6 times 5 times 4. Man, times 3 times 2 times 1. 7, 6, 5, 4, 3, 2, 1. Okay? Over N minus R. 7 minus 3 is 4 factorial. Times R, which is 3 factorial. I doubt this will come out evenly. 1s, 2s, 3s. Okay? What else cancels out? Ooh, don't forget 4. Okay? Is that right? 4. Yeah, okay. 6 times 5 is 230 times 7 is 210. Okay, it's amazing how we keep getting that number. Divided by 3 times 2 is 6 times 1 is 6. Divided by 6. That does not come out evenly. However, they're both divisible by 3. Now, I'm going to show you this shortcut you should have learned in the 4th grade. How did I know that those are divisible by 3? I do not just magically know that. What is 2 plus 1? 3. Plus 0? Still 3. Is 3 divisible by 3? Yes. That means if you add up the digits, and that number, whatever you get, is divisible by 3, then this whole thing is divisible by 3. So I know 210 is divisible by 3, and I just know that 6 is divisible by 3. So 3 goes into 210 how many times? Well, it goes into 21 7 times. Don't forget your 0. And then it goes into 6 2 times. 70 over 2. Okay. That just didn't seem right for a minute. 70 over 2, they're both even. 35. So we went from having, what was it, 210 ways over there, down to 35. Combinations will always be less. And we've done that example. We are good to go. Okay, I'm going to give you a worksheet. That sheet will have you do permutations, combinations, and fundamental accounting principle. It'll also make you distinguish which is which. So, good luck. If you need questions, have any questions, ask me.